Good afternoon, everyone. So last time we have seen phase diagram of sulfur. So in previous lectures we have discussed the two phase diagram, one phase diagram of water and one was sulfur. So both system was one component system, but today we are going to discuss the phase diagram of lead silver system, which is the two component system. So what actually difference between two component system and one component system? So let me explain you through the phase rule. Give phase rule. What is our phase rule? F is equal to C minus P plus 2. That is our phase rule. Two component system. Two component system. So what is the actually two component system? The system where the maximum two components are there, such type of system is known as two component system. So in phase system, we know that the sulfur is the only component to describe the composition of each phase. Therefore such system is known as the one component system. Similarly, in water system, the chemical species, that is a H2O, is there. Therefore the water system is considered as a one component system. But here the case is different, where we have two components, that is silver and lead. Silver and lead both are different chemical species. So minimum number of phases are possible. We know that for each system we need the degree of freedom to describe the condition of an equilibrium. Okay, we need the degree of freedom to describe the condition of equilibrium. So what is the degree of freedom? The physical parameters needed to describe the condition of system, that is of pressure, temperature and composition. These are maximum three variables which are we use to describe the system and the condition of system. So in this case, if we have two component system where we have two chemical species, and for two component system minimum number of phases will possible, that is a one. Okay, and maximum number of phases, that is a 2, 3, 4 number of phases, but the minimum number of phases will be possible, that is a one for any component system. If you consider here the one component system, then we need to find out the minimum number of phases. So in this case, for two component system, for dual component system, if we have the one phase, that how many number of degree of freedom we needed to describe the condition of system. Okay, so suppose we have P is equal to 1. We know that it is a two component system, therefore we have two component. So F is equal to 2 minus 1 plus 2. The maximum number of degree of freedom will be 3. So we know that if degree of freedom will be 3, then we know that temperature, pressure and composition, all these three variables are required to describe the condition of an system. Okay, how can we determine it? Using the phase rule. So if n two component system having one phase, okay, what I am saying you, if any two component system having minimum number of phases, that is a one phase, and through the one phase if we try to find out the degree of freedom, so we get 3 degree of freedom. It means we require three variables. We basically it means that we require all variables to describe the system. So basically if we need to draw the phase diagram, okay, if we try to draw the phase diagram, and if we try to describe the equilibrium through the phase diagram. So we know that we have three variables. So how can we draw the phase diagram, and how can we represent these variables in this two-dimensional phase diagram? If we written here pressure, if we written here temperature, then what about the third one, that is a composition? So basically, for 3 degree of freedom, it is not possible to construct the phase diagram. What I am saying, you just focus here. If we have two component system, okay, two component system mean we have two chemical species, silver, maybe it is a gold or maybe lead. Okay, we need the two components. So we have considered here two components, that is a silver and lead. So to find out the degree of freedom, to estimate the degree of freedom, we need to find out the minimum number of phases. So literally, if we have one phase, so using this phase, we will find out degree of freedom. So as per the one phase, we get the 3 degree of freedom. What we get for one phase, for two component system, we get 3 degree of freedom. It means we get the 3 variables: temperature, pressure, composition. So basically 3 degree of freedoms we require to describe the condition of an equilibrium. What I am saying, you, we need 3 variables to describe the condition of an system. Okay, to describe the condition of system, we need to construct the phase diagram. And on paper, it is not possible to describe, to represent these 3 variables in two-dimensional system. So to sort out such problem, mostly chemists to overcome from this difficulty, mostly they practice to considering the one variable as a constant. So for 3 degree of freedom, it's not possible to construct the phase diagram. What I'm saying, you, for 3 degree of freedom, for 3 variables, it's not possible to construct the phase diagram. Therefore, one variable should consider as a constant. One variable should consider as a constant. Simply मैं आपको ये बोल रहा हूं, टू कंपोनेंट सिस्टम है, टू कंपोनेंट सिस्टम में सिल्वर है, लेड है, ठीक है. अब टू कंपोनेंट सिस्टम के लिए मिनिमम नंबर ऑफ फेजेस हमारे पास 1. ओके, इस मिनिमम 1 फेजेस को यहां पुट करके, टू कंपोनेंट को यहां पुट करके अगर हम डिग्री ऑफ फ्रीडम फाइंड आउट करते तो हमें 3 डिग्री ऑफ फ्रीडम मिलता है. क्या मिलता है? 3 डिग्री ऑफ फ्रीडम. अब दिस 3 degree of freedom actually needed to describe the condition of an system. Means तीनों ही डिग्री ऑफ फ्रीडम की हमें जरूरत है किसी भी सिस्टम का इक्विलिब्रियम को डिस्क्राइब करने के लिए. लेकिन ऑन पेपर हम तीनों ही वेरिएबल्स को रिप्रेजेंट नहीं कर सकते. क्या कह रहा हूं मैं? तीनों ही वेरिएबल्स को हम यहां पर नहीं बता सकते. अगर हमें इसका फेज डायग्राम ड्रॉ करना है इन तीनों ही वेरिएबल को कंसिडर करते हुए, तो हमें 3 डायमेंशनल फेज डायग्राम ड्रॉ करना होगा. एंड टू ड्रॉ द 3 डायमेंशनल फेज डायग्राम इट्स रियली कॉम्प्लिकेटेड. Therefore, to avoid such confusion, what we do, we consider one variable as a constant, as a fixed. What we do, we consider one variable as a constant. So suppose if we consider pressure constant, then we need to describe temperature and composition. Therefore, now it is possible to draw the phase diagram. If we consider one of them as a constant, then it is possible to draw the phase diagram. Okay, you just remember this concept here. Okay. Now just focus here on phase rule. Just focus on phase rules. What I am saying, you, अगर हमें 2 डायमेंशनल फेज डायग्राम ड्रॉ करना है तो हमें किसी 2 वेरिएबल्स को लेना होगा और किसी एक को कांस्टेंट मेंटेन रखना होगा। सिंपली अगर हम प्रेशर ले लेते तो हम एक फिक्स प्रेशर यहाँ पर मेंटेन कर लेंगे, कांस्टेंट 1 एटमॉस्फेरिक प्रेशर suppose, and we will find out the variation in temperature and composition. Okay, but if we disturb the pressure, then all phases, all composition of all phases will be disturbed. Okay, then to draw the two-dimensional system we need to fix the one system. Now you can just focus here on this phase rule. F is equal to C minus P plus 2, where 2 is two variables, temperature and pressure, and C minus P describe the composition that we have discussed already in derivation for phase diagram, phase rule, sorry. This expression we have seen in detail in for derivation of phase rule. Okay, so these two are the variables, temperature and pressure, and this indicate the composition, that is the third one variable. If we put the pressure, if we take as a pressure as a constant, then we need only two variables to describe the phase diagram. Okay, so here we do not need to use pressure. So what will we do? We reduce the one variable into one. So this equation will become F is equal to C minus P plus 1, because we know that we are using only two variables, the temperature and composition, and the third variable we are maintaining the third variable as a constant. Okay, so we do not need the pressure to describe the equilibrium, because we are not considering the pressure here. Okay, so basically this equation reduced into this form. This two indicating the two variable, temperature and pressure. This term indicating the composition, that is the third variable. So we are reducing one variable from this equation, so we get reduced form of phase rule, that is F is equal to C minus P plus 1. Okay, because in phase diagram we are going to describe only temperature and composition with keeping pressure as a constant. So we do not require pressure to describe the variation between the composition. Okay, so for such type of phase diagram we will use this reduced form of phase diagram. What I am saying you, for such type of system we will use reduced form of phase rule. You just write down this equation at any corner of your notebook for your memory for your memory. Now talk about the system. This is the actually basic for that what kinds of phase rule will require for such system. Now talk about the two component system where silver and Pb are there. So basically we know that if we add the two metals, what we do, if we add two metals, suppose this is a metal 1 and this is a metal 2. If we combine these two metals on heating, so what will be the possibility? We get the alloy. What is the alloy? You already heard about the alloy. Do you know about the stainless steel? Stainless steel, it is also the alloy. There are number of alloy. So what is the alloy? What is the alloy? It is a mixture of two metal. It is a mixture of two metals. So here we know that silver and lead, also the metals. If we try to form the alloy of silver and lead, so basically we need the phase diagram to describe its composition. So any kinds of alloy you have to consider, it contains this particular composition. Any types of alloy which contain the particular type of composition. Suppose stainless steel, I'm just considering as a general example, where the 20% of one metal and 80% of other metal. 30% of one metal, 70% of other metal. So these are the different composition for alloy. Okay, but we need the more basic information about the silver and lead. Just a minute. Classification of two components. There is classification as given in your textbook. So they are classified in three different types. If the two components are completely miscible in the liquid phase. So basically, two component systems are divided in three different forms. Suppose we have two component, it is a possible that they can completely miscible in the liquid phase. When both metals are in liquid, so it is possible that they can be miscible to each other. Second classification, in the liquid phase two components are partially miscible, so it is also possible that they can partially miscible and partially immiscible. And the third one, in liquid phase two components are not miscible, that is immiscible. So these are the three basic types of classification. But here we are going to particularly discuss about this system where we have silver and we have lead, two component system. And we know that in liquid form silver and lead both are completely miscible. What I am saying, you always remember the one thing here: silver and lead completely miscible at liquid form. At liquid form means when both are present in liquid form, they can miscible to each other and they will form homogeneous mixture. But the magical thing is there, they can completely miscible to each other, but even though they are not able to form the third component. What I am saying you, silver and lead at liquid state at completely miscible, they can form the homogeneous mixture, but even though they are not form third compound. Means we know that if we add compound number A, compound number 2, so it is possible to the formation of compound number 3. This is a basic concept of chemistry. If we take one chemical species and we add second chemical species into the first one, that it is possible that we get the third one. It is a chemistry actually. But if you take the silver in liquid form and lead in the liquid form, and if you mix together to each other, then you get the homogeneous mixture, and it is possible to getting the third one component here. But silver lead, even though it form the homogeneous mixture, but they will not form the third chemical compound. That is the nature of silver and lead. You must remember the thing here. Okay, now talk about the phases of silver and lead. So how many number of phases actually possible? How many number of phases are actually possible for silver lead system or lead silver system? So basically there are 4 phases are possible for such system. First one, that it is possible that solid silver, solid lead, and the molten solution. Means both are present in liquid form. Such solution is known as the molten solution of silver and lead. And the last one phase, that is a vapor phase. Now here will be the most important concept. You can focus here. Silver lead system, two component system having the 4 phases: solid silver, solid lead, solution of silver lead, and its vapor. You know that the system the phase diagram system of silver lead, it is a condensed system. It is the condensed system. And in this condensed system, we are not considering the pressure. Basically, this form of phase depends on pressure. The last we have seen already in sulfur system and water system that the vapor phase basically depends on pressure, but we are not considering here pressure. We are just keeping the pressure as a constant. So we are not need to write here vapor, so we will ignore vapor phase in such system. And even though this system is a condensed system where the pressure is constant, so if we change the pressure, so the minor pressure does not affect the vapor. Therefore, we will not consider here the fourth phase, that is a vapor phase. So the vapor phase is ignored in this system. So this system, the silver and lead system, is considered as the condensed system where the pressure is constant or fixed. So there will be only three possible phases: solid silver, solid lead, and solution. It means that the molten solution of silver and lead. So what I am saying you, the fourth phase, that is a vapor phase, is ignored or avoided. You must remember that. Why the fourth phase is avoided in such system? Because it is the condensed system first of all. What is a condensed system? Because it having the fixed pressure, fixed pressure, that therefore it is a condensed system. So pressure, the fixed pressure does not affect the vapor of metals. Therefore we will avoid here the vapor phase. So we have to consider here only three phases: solid silver, solid lead, and solution, basically the molten solution of silver and lead. And you can say the solution of silver and lead means both are present in liquid form. That is a solution of silver and lead. Okay, now let's come on our topic. So we have the phase diagram. You must remember that the one thing here, from last month I am consistently noticing that only few students are attaining the lecture. So you must remember that organic, inorganic, analytical, industrial, all subjects you can learn, you can study on your own basis. Okay, but if you want to learn the physical chemistry, so you should have to attend the lecture. Without lecture, you are not going to understand the concept of physical chemistry. You must remember that. The most of students just can come here to attendance and they leave the lecture. So I must suggest you that you should have to attend the lectures to understand the proper basics and concept of physical chemistry. Either it will be more difficult for you. You must remember that. It will be more difficult for you. Now you can see here that we have the phase diagram. Phase diagram of lead silver system. So you can see here at left hand side. At left hand side you can see the 100% silver. Okay. At right hand side we have 100% lead. Okay. So at left hand side we have 100% silver but 0% lead. Means at that point we are not still added the lead. Okay, but similarly at this point we have 100% pure lead. So it means that there is a 0% of impurity of silver into the lead. Okay, hope you clear all the both points. Now you can see here at 960 961 degrees Celsius. Actually, it is a melting point of pure silver. What is that? 961 degrees Celsius. It is the melting point of pure silver. On other hand, at this point, 327 degrees Celsius, it is the melting point of pure lead. Means at this point, it is started to melt. Okay. Now, just consider the area in between these two pure form of metals. Okay. So suppose at this point we have 100% silver and the silver having 961 degrees Celsius, and if we heat up this silver at 961 degrees Celsius, so basically at 961 degrees Celsius silver present in liquid form. Okay. So from here, if I begin to add the lead into pure silver. What I am doing here, you can just focus here. It is one of the simplest phase diagram system of lead and silver. At this point, 961 degrees Celsius, the 100% pure silver. If we begin to add the lead into the pure silver, what will happen? What will happen? The melting point of silver get reduces. As far as I started to add the lead into the silver, then what will happen? The melting point of silver get reduces. So basically, if I add 1% of lead into the pure silver, then I get the mixture of, I get the composition of silver and lead. So basically at this point, if I added 1% of lead, what I am doing, I added 1% of lead into the 100% of silver, then what will happen? The melting point of pure silver get reduces. So ultimately at this point we have composition of silver and lead, where the silver 99% and lead, that is 1%. So at this point the mixture will be melt. So what changes has been carried out in this system? After addition of lead into the silver, the melting point of silver get reduces. Okay. So from here we are adding lead, and there will be the formation of composition at different addition. So you can see here we are describing by using the terms, that is a composition. Okay. So at each addition, we get the different composition. We get the different composition of silver and lead, with decreasing the melting point of pure silver. ठीक है. तो सपोज क्या इस पॉइंट पे हमारे पास 100% सिल्वर है जो मेल्ट फॉर्म में 961 डिग्री सेल्सियस के ऊपर. अब इसी पॉइंट पर मैं स्टार्ट करता हूं लेड का एडिशन. तो जब मैं लेड इसमें एडिशन करना स्टार्ट करता हूं, तो हर एक एडिशन के बाद जो मेल्टिंग पॉइंट था प्योर सिल्वर का, क्या होता है? रिड्यूस होना शुरू हो जाएगा. बिकॉज एट दिस पॉइंट आई एम गेटिंग द कंपोजिशन. जैसे ही मैंने लेड ऐड किया तो मुझे क्या मिलेगा? कंपोजिशन ऑफ सिल्वर एंड लेड. Again, if I added the lead into the silver, I get the other composition. If again I added the lead, I get the other composition. So basically I am getting the alloy of silver and lead at particularly addition. And what is the changes has been taking place in this system? The melting point of silver getting reduces. Okay, hope you understand the concept. Now, so we having the curve A and C. We having the curve A and C. This curve describing the equilibrium between solid silver phase and solution of lead in silver. So this curve describing solid silver phase and solution of lead in silver. So you can see here this portion having solid silver plus solution of silver lead, or you can say the solution of silver in lead, means molten solution of both metal, means at particular composition we having solid silver as well as liquid silver and liquid lead, means molten homogeneous mixture of both metals. What I am saying you, after each addition we are getting solid silver and as well as liquid form of silver and lead. So basically this curve A and C curve describe the two phases. What it describing? The two phases. The first one, that is a solid silver, okay, and the liquid of both metals, means molten solution of silver and lead, or you can say that solution of silver in lead. So this curve at this point, we will come later on this point. Now discuss about the curve BC. You can see here the curve BC. Again, at this point, we have 100% pure lead. Okay, and the melting point of pure lead, that is a 3 to 7 degrees Celsius. Means at this point the lead transform into liquid form. Okay, so from here, if I try to add silver, at this point we have 100% lead. So similarly from this point we are started to adding the lead. So similarly from this point, if we started to adding silver into the lead, so what will happen? Against the temperature melting point of lead get reduces. What will happen? Here we have the 100% pure lead, that is a melting point at 3 to 7 degrees Celsius. But if we're trying to add the silver into the lead, then the composition that we have having the lower melting point as compared to the pure lead. So basically the melting point of each composition after each addition get reduces, and the point that we get, both curve are meet at point, that is a point C. So both curve, that is the AC curve and BC curve, both curve are meet at the point, that is a C point. And you can see the temperature of C point 303 degrees Celsius. So this the last point, the last temperature at which the possibility of both metals may present in liquid form. Focus in each word. Okay, ये ऐसा लास्ट पॉइंट है जहां पर दोनों कर्व मीट हो रहा है, दोनों कर्व यहां पर आकर मिल रही है, और इस पॉइंट का टेम्परेचर है 303 डिग्री सेल्सियस. तो मीन्स ये लास्ट पॉइंट है जहां पर सिल्वर एंड लेड बोथ may be present in liquid form. It is the last point. It is the point at which the maximum amount of metals get mixed to each other. ये ऐसा पॉइंट है जहां पर मैक्सिमम अमाउंट ऑफ मेटल, जो लेड का, सिल्वर का मैक्सिमम अमाउंट क्या है 2.5% और लेड का मैक्सिमम 97.5%. मींस यहाँ पर मैक्सिमम अमाउंट दोनों का मिक्सअप हो रहा है, होमोजीनियस मिक्सचर फॉर्म कर रहा है. एक्चुअली हर पॉइंट पर होमोजीनियस मिक्सचर फॉर्म होगा, लेकिन पर्टिकुलरली इस पॉइंट पर जो मिसिबिलिटी है, मैक्सिमम मिसिबिलिटी इस पॉइंट पे, तो आप देख सकते हो 2.5% सिल्वर है और 97.5%. तो मैक्सिमम अमाउंट है, मींस इससे ज्यादा ये मिसिबल नहीं हो सकते. सपोज 2.6% सिल्वर क्या मैं इसमें मिजिबल कर सकता हूँ 97.5 में? नहीं कर सकता हूँ। तो मैक्सिमम लिमिट क्या है इस पॉइंट पर सिल्वर का? 2.5%। मीन इससे ज्यादा सिल्वर इसमें मिसिबल नहीं है। और ये कंपोजिशन जो प्रेजेंट है, इट इज प्रेजेंट इन लिक्विड फॉर्म, and this is the last temperature where both miscible mixture are present in liquid form, in homogeneous form. This is the last temperature. If we reduce the temperature from 303 degrees Celsius, if we reduces the temperature 303 degrees Celsius below the 303 degrees Celsius, then what will happen? Both are transformed into solid form. Okay. Now, so what is actually point? What is actually this point? This point is known as eutectic point. What is this point? It is the eutectic point. You just highlight this point, the one of the important concept, and always the question has asked on this point, eutectic point. Now let me explain you what is actually eutectic point. In previous phase diagrams, we have seen the triple point. Okay, you know the triple point, the point at which all phases are present. So basically, similarly, the eutectic point, the point that is a triple point, which contain the all phases of system. So maximum phases we have for this system: solid silver, solid lead, and molten solution of silver and lead. Maximum phases, 3 phases maximum phases. So what will be the possibility and of phases at this point? So maximum phases present at this point will be 3. So actually it is the triple point of lead silver system. So particularly this point is known as the eutectic point. Is silence here. Eutectic point, where the all phases are present. Phases are solid silver also there, solid lead also there, and the molten mixed solution of both metals are moles is also there. Okay, so such point is known as eutectic point. And you can also say that both curve are meet at this point, where the phases solid silver, solid lead, and solution of silver in lead is observed. The composition of this solution is 97.5% and 2.5% of silver. So at this point, the composition of solution or molten solution will be 97.5% lead and 2.5% of silver, and at which all phases are in equilibrium is called as eutectic point, and all phases are in equilibrium. Maximum phases are there, 3 phases. First one solid silver, solid lead, and both are in molten form, means solid liquid form. So all phases are present at this point, and all phases are in equilibrium. And those molten solution or molten liquid composition 97.5% lead and 2.5% silver. So you must remember the eutectic point, the one of important topic, and always the question has set up on this type on this topic. Now talk about the degree of freedom for this curve. We know that this curve representing showing the equilibrium between solid silver phase and solution of solid and lead. So 2 phases, this curve showing the 2 phases. Let me write here the curve AC. The curve AC, you can see here the curve AC having the 2 phases. So we have phase rule. F is equal to C minus P plus 1. We have the phase rule, that is a reduced form of phase rule. Why the phase rule get reduced in this form, we already discussed. Okay, so hope it's not need to explain you again. Now, so we have the phase rule, and we have the curve AC curve, which is which having the 2 phases, and we know that the component, that is a 2 component, So f is equal to 2 minus 2 plus 1. So we are getting the degree of freedom, that is 1. So AC curve is showing the equilibrium between solid silver and liquid silver in lead, which having the 1 degree of freedom. So this curve, the equilibrium between this curve, the equilibrium between this curve, that is a monovariant, because we know that we have the 1 degree of freedom. The curve will be monovariant. It is audible. Can you hear me? Let me know in comment box. Mistakenly the mic has off. Okay, the mic is now. I turn on the mic. Okay, once again I am repeating here. So we have the region, areas, the region below the curve ACB, such area is referred as ACB. In such area, we have metals which are present in liquid form. And if we try to find out the degree of freedom for this region, so we know that the only one phase is present here, that is a liquid phase. And if we try to find out the degree of freedom for this region, then what will be the degree of freedom for this region? The reduced form of phase rule, F is equal to C minus P plus 1. So phase, that is a 1, number of component, that is a 2. So 2 minus 1 plus 1 is equal to 2. Okay. So this region in system is bivariant. Okay. This area is considered as a bivariant. The question may framed on this type of region. So you must prepare for this question also. Now talk about the region or area between A, D, C, E. A, D, C, A. So you can say the A, D, C, A, D, C, A. So basically the region between this point A, D, C, A, such region having and silver. In this particular region, we have solid silver plus molten solution of silver and lead. Okay, and if we try to find out the degree of freedom for particular this region, so we get the similar region, hence the composition of solid. Okay, again the last one region, BECB, B, B, C, E, B. Okay, the region between B, C, E, B. Actually, I am talking about this region. Okay, so again in this region we have solid lead plus solution of silver in lead. Okay, now talk about the last region, DCE, the region below the this point DCE, the region below the DCE, such region is known as DCE, which give the solid. In particularly this region, we have solid silver, solid lead, and eutectic composition. So from this point, if we reduces the temperature, then what will happen? The liquid form of metal turns into solid form. So basically below this region, we have solid silver, solid lead, and eutectic mixture. Means eutectic mixture means this mixture will remain same, 90.7.5 degrees Celsius lead and 2.5% silver. The description of curve that is given in your textbook, so that already I described you, so no need to explain you again. So I'm looking forward to explain you the fourth chapter from next lecture, that is the electrochemistry, and the topic that are pending from this chapter. So you must read from your textbook, and it is a quite easy, and it is you can read easily. You can understand because we already discussed about all the concept, all the basics regarding the phase rule, phase diagram system. Okay, so hope you will not get the difficulty over these topics. So your last topic, the last chapter, that is a short chapter, electrochemistry. So more hard, probably it required the 3 to 4 lecture. So we have short time to complete this chapter. Okay, so we stop here. We will continue from tomorrow.